This video is lesson 3.2 and it's all about estimating products. So here we go. Your table of contents, there's going to be three things happening today in that. So I'd like you to write down page 7, 8, and 9 in your notebook. We're going to first be talking about those math action words that we hinted at in the video of 3.1. Then we're going to be gluing in a place value chart. And then finally, we're going to be doing some estimation. Once you're set on page 7, it's going to be just a blank lined piece of paper. I'd like you to divide that with your pencil into 4 different sections. First, I'm going to label the title, Math Action Words. Once you have the title on there, then do that T down the middle, and then splitting the piece of paper up into 4 different sections. Those 4 sections are going to represent the 4 operations. So we're going to have the addition, subtraction, multiplication, and division. So yesterday in class, we saw some word problems with some keywords that meant add or subtract. Hopefully you paid attention to those. We're just going to jot some of those down right now and add a few for multiplication because that's what we're going to focus on for lesson 3.2. The title, Math Action Words. Once you have the title on there, then do that T down the middle, and then splitting the piece of paper up into 4 different sections. Those 4 sections are going to represent the 4 operations. So we're going to have the addition, subtraction, multiplication, and division. So yesterday in class, we saw some word problems with some keywords that meant add or subtract. Hopefully you paid attention to those. We're just going to jot some of those down right now and add a few for multiplication because that's what we're going to focus on for lesson 3.2. First one, obviously, sum. There's also the word combined, increase, both, in all, and we're going to be adding to those throughout the year. For subtraction, the biggest one is difference. You see that word, you know that you're probably going to be subtracting. Another one would be just like increase, decrease. You can say how much farther, higher. Those words could change. How much faster, how much is left, tack on change. If you're dealing with money and you're asked to find change, that means subtraction. For today, we're going to be focusing on multiplication. So that, right off the bat, is product. We're going to be taking the product of 2 numbers. Other words in this lesson that you might see that mean multiplication is the word per and the word each. Like I said, this is a working chart that we'll add to as the year progresses, and I just wanted to get you started for today. On page 8, you're going to take the top half of your notes that I gave you and you're going to cut it out, and I'd like you to color it. This example has a strip of blue, strip of purple, a strip of orange, a strip of yellow, and then there's this red part, and they're different periods. So you have the yellow, ones, tens, and hundreds. That's the first 3 numbers before the decimal point. After the decimal point are all the THS's. So the hundredths, the tenths. The opposite direction the second bunch of 3 numbers is its own house or its own period. And so we have the thousands, 10,000s, 100,000s. Then, and obviously they're separated by commas. We have the millions house and the billions house. So in order to read a number, all you need to do is be able to read a 3-digit number. And you will always start and just read this 3-digit number and then say what house it's in. So 210 billion, 987 million, and you look at the last number in that chain of 3 and say that house. Then you move on to the next one, 654, and then say the house, 1,000. And then the last period, just say 321, doesn't have a house name because it's the one place that you're actually talking about now. So 321, and this is red on purpose. I would like you to color this red because that is where you pause and say and. So now we have to tackle the smaller numbers. We're going to pretend that this is a number without a decimal in front of it. So if it was a number without the decimal in front of it, it would be right here, and then there would be a comma there. So we're going to read this number as 23,000, just like we would if it was a big number, 456, but then say the place value place that this 6 is in. 23,456 hundred-thousands is how to read that number. So a quick review on place value. This is from yesterday. The only thing I want to say is that yesterday I did not talk about this example on purpose because today this lesson 3.2 is focusing all about estimation. I want to dive deeper. Remember though, the key word you wrote yesterday, you're going to see a lot today for this lesson and tomorrow when you practice it. So let me explain this example now. For example 1, the general rule is to always estimate to the largest place value place. However, there is no specific direction in order that you have to do that. So there's a couple of different ways we could answer this. We could take the 2.5 and round it to the largest place value place, which would be the 1s, and it would be a 3. And then this, the largest place value place would be that 1, and we would estimate that to be a 1. So we could get an estimate of 4. However, sometimes if we have a good number sense, we can recognize that, hey, maybe we don't want to make this bumping up to a 1. Maybe we want to say that it's close to a half and keep this the same because it's easy for us to just combine 2 halves and call it 3. So this is another estimate. Both of these are correct. That's the unfortunate or fortunate, however your opinion lies, part about estimation. You could have 2 different answers for an estimation and both of them could be right. On page 79, you're going to take the second box part of your notes. To estimate, as a rule, you want to look for the largest place value place and round to that place. And then just a little note, it's always better to estimate closer to the actual numbers because it will then be more exact if you were comparing your estimate to the real answer. The biggest thing I want you to write down and remember is that you should always estimate first. And then do your calculation. So calculate after you've estimated. Today our calculations are going to be multiplying. So right below where you had that estimating practice note sheet, you're going to have some space to do some examples with me. So when I write, you write. So here we go. You don't have to write down the original problem. The sheet of paper that I have will model what you should write on your paper. So very simply, sometimes we'll be asked just to estimate numbers. No context, no word problem. So on my paper, I'm going to label it number 1, and I'm just going to copy down the problem. 8.7 times 2.8. Now I can show my work. I'm going to circle the largest place value place, which is the 1s, and draw an arrow to the 7, and do the same for the second number. Since 7 is greater than 5, this will become a 9. Since 8 is greater than 5, the 2 will become a 3, and 9 times 3 is 27. And that's my answer. Pretty simple. For this one, same directions, there's just bigger numbers. So on my paper, I'm going to write number 2 and just write down the numbers to start. And now I'm going to seek out the largest place value place, which is the tens place. So that's the number I'm looking to possibly change, the 4 and then the 3. What will tell me it's changing? I'm going to look at the 2. It's less than 4, so I'm going to stay at 40. The 7, though, is going to make me change that 37 to a 40. 40 times 40 will give me my answer of 1,600. So now we're going to do 2 more, and they are word problems. You don't have these word problems, so I'm going to do the cube strategies just to show you. You don't have to worry about writing the entire sentence down. Just watch how I mark up the problem. So a greyhound can travel 39.3 miles per hour. At this speed, about how far could a greyhound travel in 6.5 hours? I see this as my keyword telling me I'm going to estimate. I'm going to write an EST underneath that. I'm also seeing a keyword per, which is going to tell me to multiply. So now you pick up your pencil. This is where our work will start. For number 3, I'm going to copy down my numbers from the problem, and I know now that I am multiplying them, and I have to estimate first. So I'm going to circle the 3, draw an arrow to the 9, circle the 6, draw an arrow to the 5. That will help me round to the largest place value place. I have 40 because of the 9, and 7 because of the 5, and that will be 280. The only difference now with this is that we do need a unit after. What are we talking about? What does this represent? Does it represent miles or does it represent hours? Those are the 2 topics of our problem. So I'm going to have it represent miles because at this speed, how far could the greyhound travel? That's what we want to know. That's the question. How far could it travel? Number 4, suppose $1 is equal to 5.8 Egyptian pounds. About, said about again, how many Egyptian pounds would you receive for $48.50? So here we have to recognize that this $1 is equal to. That's the math action word that we have to think about when we're trying to figure this out. So 1 is equal to 5, but we don't have $1, we have 48 of them. So we do need to multiply to figure out the answer to this question of how many Egyptian pounds. That's what we're trying to find. We know how many dollars, and we know the conversion. 1 is equal to 5.8. So now we need to multiply these 2 numbers to find our answer. But it's not the exact answer, we're just doing an estimate. So similar to number 3, on my work paper, I'm going to put number 4 and I'm going to copy down the numbers. And I know I'm multiplying after I estimate. So the 5 is going to look to the 8 to make it a 6. The 4 is going to look to the 8 to make it a 5 or 50. And now we are left with 6 times 50 or $300. Notice that dollar sign is the unit. So sometimes they're just flat out estimations, no context, no word problems. Sometimes there are word problems involved. The last thing we're going to talk about is explaining our thoughts. Oftentimes this year you're going to be asked to explain your reasonings or to prove it. Now, sometimes people get nervous about this. Don't worry. All it means, though, is that you're going to have to write an answer in a sentence. For this justification or proving your answer, we're going to be answering, why is our estimate reasonable? Or why is someone else's estimate okay? Or the questions could vary a little bit, but at the end it would say explain or justify. So here's an example I just want you to listen from your book, actually. So Patrice has $20 to buy 5 binders. Binders cost $4.29 each. Does she have enough money? Explain your reasoning. So if I were to mark up this, the 20 is important, the 5, the 4.29, and that each is telling us that we're going to be multiplying. Does she have enough money is our question that we're answering, and we have to explain. So we have to think about this in what could it be if we estimated low, what could it be if we estimated high? Because 4.29 is right in between 4 and 5. So if it was $4 and we wanted 5 of them, it would cost us $20. If it was $5 and we wanted 5 of them, that would cost us $25. So when we are explaining, we need a written answer in a sentence or two. Since we know she has only $20, when we estimated on the low end, it was $20. Do they cost $4 only? No, they're a little bit more. So the actual cost is between 20 and 25. It's not 20. So she needs more than 20. And so my sentence here is, so Patrice does not have enough money to buy them. And again, your justification can be not exactly what is written here, but it does require you to explain with numbers and a sentence. The last thing that you're going to do is try one on your own, and then I will come back and explain, but I do want you to try this on your own, so pause after I explain the problem and try it, and then replay to find out if you were right. So here is the last question. This is about a part-time job that Hannah has. She is working at an ice cream shop, and she is going to be making $5.85 an hour. So Hannah's hourly wage at the ice cream shop is $5.85. The table shows the number of hours she worked, Monday through Friday. She estimates her earnings to be $120. Without calculating her actual earnings, determine if her estimate is more or less than her actual earnings, and then explain. So in order to figure out this problem, we want to estimate, because it tells us we don't want the actual calculation. So if her earnings are $5.85, let's simplify that by estimating it to be $6. Now, did we estimate up or did we estimate down? We estimated up, so I'm going to draw an arrow reminding me that that's actually higher than what she's really making. Now I'm going to do the same thing that I did for her wage, her earning per hour for the table. So I'm estimating, so it's not exactly equal, but 3.5 I'm going to bump up to 4, and I'm going to draw an up arrow. 4.25, I'm actually going to estimate that down to 4. I'm going to draw an arrow down. For 3.75, I'm going to bump that up to 4. 2.50, I'm also going to bump up to 3. And the last one, I'm going to bump up to 5. Now I actually have to figure out how many hours is this. So 12 and 8, that's 20. So 20 hours, and we are estimating $6 an hour, that is $120. Luckily, that is exactly what Hannah estimates. So we're estimating the same, that's good. Now we have to decide, is this number, 120, more or less than what she'll actually earn when we actually get out the calculator and figure it out? The answer is that this estimate is more. The estimate is more. So this is the answer, but now we have to explain, why did I say it was more? It's more because we estimated up to 6 and up, 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 up. We rounded up for 1, 2, 3, 4, 5 of the numbers we needed to work with. Since the wage, that's how much she's making, and hours are rounded up, the actual total will be less than the estimate. That is one way to explain why 120 is more than her actual earnings. So tomorrow in class, we're going to practice this more. We're going to practice justifying with sentences and explaining ourselves and proving how we know what an answer is. And I look forward to seeing you then.